Hi, this is Miss McBride, and we're going to be working on PowerPoint 4.1, which is the beginning of Chapter 4. In Chapter 4, we're going to be doing computation, so you will want to have your graphing calculator. I'm going to be teaching you some skills on how to find some information. In 4.1, we'll be talking about mean, median, and mode, as well as what's called a weighted mean and how to appropriately use those. And in later sections, we'll be looking at things called a 5-number summary. We're going to be looking at the standard deviation. So all these things you're going to want your graphing calculator to find for you if the data sets are bigger than just a few numbers. So go get your graphing calculator. You're going to be learning how to use it. All right, so mean, median, and mode. Most of you know these definitions already. They're measures of center in a distribution. The mean is what we usually think of as average. We add up all the values and divide by the total. The median is that middle number. Now you do have to sort the data first and then find the one that's halfway between the two middle values. And third, the mode is the most common. You can find the mean and the median on your graphing calculator, but the mode you cannot. So the mode you just have to sort the data and then look for the one that's the most common. This diagram just does a good job of explaining how a mean is really kind of a balancing position. So even though you got some really big numbers on the left, the total of the smaller ones over, or sorry, I always get my left and my right mixed up. You would know that if you were in my regular class. I'm always pointing, sorry. Anyway, that big pink one over on the right side is the biggest one, but because you've got like the orange, yellow, blue on the left side, it kind of balances each other out. So that mean is that balancing or center point. All right, so now this is a very important rule for rounding, especially when you're working on MyStatLab. State your answers with one more decimal place of precision. Remember, that's how many decimal places than is found in the raw data. So if we are finding the mean of these whole numbers, 2, 3, 4, 5, they have no decimal place, so we would round to one decimal place, or 3.3. This is really important. Always round only your final answer and not any intermediate values. And I'll talk about this a lot as we use your calculator. So if you're finding the mean of these 8 grocery stores, notice you have 1.09. I have 2 decimal places. So when we find the mean, usually you would take it to 3 decimal places, but money is a funny thing. Sometimes you want to go ahead and round it to 2 because that's actual money, like if you had to give somebody some, or if they're talking about the theoretical mean, you might take it to 3. All right, so we're going to find the mean, median, and mode, and I'm going to have you use your graphing calculator to do it. So get it out. All right, so here's your mean price. They tell me is $1.41. Okay, so here's an example of money you would just always take to 2 decimal places unless told otherwise. All right, so go watch the little video if you haven't done that already. But basically, you turn on your graphing calculator by going to On, and then you find the Stat button, S-T-A-T. You will see in front of you a menu that says Edit with Edit highlighted. You hit Enter to pull that up, and then you'll see a screen with lists, L1, L2, L3. And in list 1, if you already have stuff in it, you can overwrite it or delete it, or I show you how to delete the whole list on the little video. But you just go ahead and put in your numbers. So hit pause and put those numbers in, 1.09, etc. All right, once you have those all in, then you go back to your home screen by quitting. Second mode gets you to the home screen. Then I do Stat, and now I cursor over to Calculate, C-A-L-C, and number 1, one variable stats is highlighted, and I click Enter. Then I want to choose the list that I want to do the statistics on. So notice L1 is above the number 1 on your graphing calculator. On mine it's in blue, other ones it's color coded. So I hit the color button that matches the L1. So I'm going to hit blue button L number 1, which will access L1 for me. And again, this is on the video if that doesn't make sense to you. And then I hit Enter. And the mean is called X bar, is the X with the little line over it. That will be the first thing you see. It should say 1.41. All right, let's find the median. If I do it the long way, I split up my values to get it, since I had 1, 2, 3, 4, 5, 6, 7, 8, I have an even number of values. I have to take the average of the two middle guys. If I have an odd number, I just take the one that's in the center. Now, on your calculator, if you just hit your little down arrow button right above the clear, and you scroll down, you'll find something that says MED. Should say 1.37, because that's the median of this data. So using our rounding rule, we could express the mean and median as that 1.410 or 1.370 if I needed that extra degree of precision. Now, okay, we already did the median. You just scroll down. The mode, you can't do your calculator on that. So when I say to do that, that's wrong. You can't find the mode on the graphing calculator. Now they also have instructions on Excel, but I want you to get used to putting data into your list and finding the mean and the median, as well as later on you're finding the standard deviation. All right, now just to note that that measure of center has the same number of significant digits as the original data, so you can either include the extra 0 or use the exact result. For example, the mean of 2 and 4 can be expressed either as 3 or 3.0. Your calculator sees those two the same way, but to be correct, you really want to do the 3.0 to get that one more degree of precision than the original data. All right, outliers. Remember, outliers are data that are way above or way below the rest of the distribution. So what happens if we see these numbers are the excuse me, the first year contract offers to play basketball, 0 indicating the player didn't get a contract offer. Now if I ask you what is the average of this, most of you will automatically add those 5 numbers and divide by 5 and get some crazy high number, which really doesn't indicate the average offer to these players. So in this case, the mean is not a very good indication, because it says everybody's getting around $700,000 and they're not. 4 are getting nothing and 1's getting 3.5 million. So instead, it's not fair to say that that was an average. So instead, that really large offer makes that outlier of the mean, or sorry, the outlier of that one data value pull the mean much higher than it should have been. So if we ignore the one player and look at the other 4, the true mean contract offer is 0. So that thing called an outlier in the data is a value much higher or much lower than almost all the others. It's way out there. It's an outlier. So in general, the value of the outlier has no effect on the median, the middle number. The middle number isn't going to change, but it does affect the mean. It doesn't really affect the mode either. So when we have something with an outlier, it's better to use the median or the mode, depending on the type of data, than using the mean. So this little table compares them, and this is a rather important table here. So here's our definitions, mean, median, and mode. Then how to find those is the second column. The third column is how common are these things. And notice the mean and the median are the most common, but we have to be careful. Existence, the mean always exists, the median always exists, but there may or not be a mode. It could be uniform, remember? All right, so takes into account every value. Yes, the mean. No, it does not take into account all the total values. So that's why it's good if I have an outlier, which is the next column. So is the mean affected by outliers? Yes. Median and mode? No. So my advantage is then I would want to use the mean because it's commonly understood. It works well with statistical methods, but the disadvantage is that if there's an outlier, it pulls the results. We'll talk about skewness next chapter or next section. All right, the advantage of a median is while there may be outliers, then it's a better representative. So if you have an outlier, the median is your better computational one. And the mode is used for qualitative data because you can't do the numeric data. So mode's best used for qualitative. So again, that leads to this confusion about the term average. So be careful when they're talking about like an average house price. If they're using the mean, that means if you're selling your house, you want to use the mean if you had a higher price in the neighborhood. But if you're trying to buy a house, then you want to use the median if there's that higher price, because you want the average of the neighborhood so you don't overpay for your own house that's not atypical. So another example here is wage disputes. So a newspaper surveys wages for workers in a regional high-tech company and reports an average of $22 per hour, and they just use the word average. They don't tell if it's the mean, the median, or the mode. Usually it would be either the mean or the median. So the workers at one large firm immediately request a pay raise, claiming they work as hard as employees at other companies, but their average, that word again, is only 19. The management rejects their request, telling them they're overpaid because their average wage, in fact, is $23. How can they both be right? Well, it all depends on how you're deciding on average. Is it median? Mean? So in the case of the workers using the median, you could have 19, 19, 19, 19, and 39. And then, 19 is the average if it's the median. But the mean of those same 5 numbers is 23. So if those are the wages they were looking at, both are correct. So if you hear somebody say that's the average, make sure to ask them, is that the mean or is that the median? That's an informed consumer. And again, especially when you're talking about housing prices or something that's decided on based on what they call comps or things that are, typical of a region, then you want to make sure you know if they're using the mean or the median. The median is best if you've got some of those outliers. The mean is best if everything's fairly closely grouped together. All right, now a weighted mean is something that you use to find your grade. So this is an excellent example. So everybody always says, what grade do I need on the final to pass your class, Miss McBride? And I pull out my weighted mean and say, here you go. This is how you figure it out. So you take your quiz score of 75 is worth 15% of your grade. So notice in the numerator there, you multiply those two things together. Then you're going to add your 80, which is worth also 15% of your grade, and 84, which is worth 15%, because remember, each quiz is 15%. My 88's times my 0.15, but my final is worth 40%. So I have to add 96 times 40. This properly weights each grade. They're not all even. Then in the denominator, you add up those weights. So you had 4 grades worth 15%, so 15 plus 15 plus 15, 15 plus 15, plus the weight of the 40. So notice the denominator should be 100 there because you want that to be 100% of your grade, and divide it by the points you've gotten by multiplying your weights, and there is your grade. You now have a B. So following that rounding rule, remember these are no decimal places, so we're going to round this to 1 decimal place. That's 1 degree of precision more than the data. So here's your little formula for the weighted mean. It accounts for variations in relative importance. So if you assign an importance to something, then you have to weight it according to that importance. So you take the sum of each data value times its weight. So the example helps you see what that means, divided by the sum of all the weights. So make sure you do the weights, but you drop the percents. All right, so because the weights are percentages in the course grade example, you can also think of the weights as 0.15 and 0.40 rather than 15 and 40. And recalculate, you'll get exactly the same answer because you end up dividing by 1 instead of 100. So the ratio, or the division, comes out exactly the same. All right, now you are going to be looking at means with summation notation, but we're using our graphing calculator. So I'm not going to be asking you to be able to use the sigma notation, but it is interesting to look at if you've taken other math classes. So if we want to sum up or add up all the values, we use this Greek capital letter called sigma. So sigma x, we'll see this more in formulas we're using in the future. So I just wanted to point it out to you. It's the sum of all those values, sigma x. This is a variable you want to become familiar with. Lowercase n represents the total values in the sample. So if you go back and look in your graphing calculator when you did the price data value, there's going to be an n equal, and I think it was 5 data values, I can't remember. And I don't want to flip back to that slide, but n equals that number will be sitting right there. It tells you how many values you've taken the mean of. So to find your formula, we said at the beginning, it was the sum of all the values divided by the total. So in formula notation, that would be sigma x, add up all the data values, divided by n, which is the sample size. Again, take note of this other variable, x bar. That's how you read that x with a little line over the top is the standard symbol for the mean of a sample. So when we're dealing with the mean of a population, we're going to use the Greek letter mu. It's like what a kitty cat, mew, mew, mew. So it's a scripty looking, weird looking U called mu. You should start a page with these variables because we're going to be using them in formulas a little bit as we go. So there's 3 variables on this page you should make a note of. N is your sample size, x bar is your sample mean, and mu is your population mean. And some of the formulas we have later use both x bar and mu. The weighted mean is the sum of all, and I multiply the x times the weight and divide it by the sum of the weights. All right, so let's take a look at some examples from the book. All right, average and mean, do they mean the same? No, we've already said that. Average could be mean, median, or mode. Mean is the sum divided by the total. Number 2, here we have a stats class consisting of 24 students, all but one who are unemployed at low-paying jobs. One student works as an executive secretary earning $75,000. Which does a better job of describing the income of the typical student, the mean or the median? All right, so this one should be pretty clear that the median would be better because you have that one outlier of that executive secretary. That would pull the mean average higher than it really is. So the median is better. So for number 3, for the same stats class described in exercise 2, is it an outlier? Yep, because it's way above. In general, is an outlier defined in an exact way? Here, we've just generally said, no, it's something beyond the typical, but there is a mathematical formula for it. We just aren't going to worry about it in this class. All right, mean income. An economist wants to find the mean annual income for all the adults in the United States. She knows it's not practical to survey each member of the adult population, so she refers to an almanac and finds the mean income listed. She adds the 50 states' means and divides by 50. Is this result of the mean a good picture of the United States? Well, it seems really reasonable, right? You take each of the 50 states where you already have a mean and find the mean of that, but actually it doesn't work because of the weighting problem. You have some states like Texas that is so many more people in it than, say, Vermont, that the weighting is out of scale here. So if you wanted to do this properly, you would actually want to do it as a weighted mean and find the population of each of those states and multiply that in. So the way it's done would be very inaccurate. All right, does it make sense? For example, 5 through 8, decide whether it makes sense or not. Let's see why or why not. All right, can we find the mean for the number of the jerseys of the New York Giants? Well, you could, but the mean means absolutely nothing. So it would not be a good measure of anything. Could you find a data set of incomes number 6 that has modes of 50,000 and 80,000? Sure, you've got something that's bimodal. For whatever reason, it could be you took the incomes of both salaried workers and their bosses, and you could have a bimodal thing for income, no problem. All right, number 11, ages. The following ages of a survey respondents were 22, 19, 21, over 65, and over 80. Sure, we could do that, but we couldn't really find the mean too well because we've just got a lumpy groups at the last two. Could you find the mean for the pulse rate? Yes, I could. Just add it up, divide, nothing special there. All right, so let's do 17 and 22. All right, so if you haven't watched the little video yet on how to put this in your calculator or follow the instructions, do so. But go ahead and just put those numbers in your calculator by going to Stat and then Edit and put those into L1. Then quit out of that and go to Stat, Calculate, one variable statistics, and hit Enter. X bar at the top should be your mean, should be 0.188. Scroll down to find your median, MED, should be 0.165. The mode you can't have on your calculator, so you have to look at the values and go, oh, the most often there is 0.16. So that would be your mode. For number 22, we have an outlier here where they vary slightly. Here are the measured weights of the 7 cans. So find the mean and the median. So again, put those in your calculator. Your mean should, and hit pause while you do that, and then start again here. For part A, your mean should be 0.8124, and your median should be 0.8161. Now part B, which if any of these weights would you consider to be an outlier? That 0.7901 is actually quite a bit lower than all the other ones, which are up in the 0.81 area. And then part C, what is the mean and median if the outlier is excluded? So go back to your calculator and re-enter the list, but only put in the 1, 2, 3, 4, 5, 6 values and leave out the 0.7901. When you recalculate that mean, you should you should get a mean of 0.8161 and a median of 0.81. Okay, I'm not real sure where this left off. I was trying to work on examples of weighted means and I accidentally hit a wrong button. So I'm picking up with number 30 on final grades. Again, this is a question I get asked all the time is, what do I need to get on this final exam in order to get an A in the class or a B in the class? So this is a weighted formula that's nice. Now we did one of these similar in the PowerPoint, where we've got a weight of 15% for the final, for the midterm. You have a project that counts 20%, homework assignments are 40%, and a final exam it's 25%. Your midterm score is 75. Here's your project score, your homework score, and your final exam score. So what's your overall final score? And this is how you find a weighted grade for any class. All right, so I'm just going to get my calculator out because I'm going to multiply as I go. All right, so I need 15% of my final grade is the midterm. So I'm going to put this into decimal, 0.15 times, I need my midterm grade, which is 75. All right, plus, now I need my weight for my project is 20, so 0.2 times the grade I got on the project, which was 90, sorry. All right, plus, that was project 20%, my homework's 40%, so 0.4 times my homework average, which is 85, plus my last one is 25%, 0.25 times my homework score of 85, and then I would divide that by the sum of the weights, which is just going to be 1. So my grade turns out to be actually that final exam score is 72. So when I hit enter I should get 81.25, and if I round that to following our rounding rule, I want 1 decimal place more than what we had, which was none, so I would round that to 81.3 would be my final score. So again, you multiply the weight times the score, add that all up, and divide by the sum of the weights. All right, for 35, stockholder voting. This one's the same kind of idea, but instead of actually percents, they're given their importance by how many shares they have. So one stockholder has 400 shares, The second one only has 300, and the third has only 200. The fourth guy has 100. So they're weighting the first guy as 4 times the weight as the fourth guy. The third guy has twice the weight of the fourth guy. So how do I take that into account? So in a vote on a new advertising campaign, the first stockholder says yes. The other 3 vote no. So how could the outcome be expressed as what we're calling a weighted mean? So because they get to vote their shares, they automatically get that weight. So the outcome is going to be no, because even though the first guy had more shares, the other ones bonded together to get 300 plus 200 plus 100, which was 600 votes, to the one guy's 400. So that's how you could express that as a weighted mean, is 1 times 400 for the first, and then 1 times 300 plus 1 times 200 plus 1 times 100, and you end up with your vote is a no. So sorry, majority guy didn't get his way. All right, and number 36, GPA. How do we calculate a GPA? Grade point average. So a common system, which is the way our school does it, you get 4 points for an A, 3 for a B, 2 for a C, 1 for a D, and none for an F. So what's the GPA of a student who gets an A in a 4-credit class, a B in each of 2 3-credit classes, and a C in a 1-credit class? Now the easiest way to work this one out, and what I just did here on my paper, is to write down the grades in the class. So I got 1 A for 4 credits, 1 B for 3 credits, a second B for 3 credits, 1 C for 1 credit. All right, so what I have to do is figure out how many points I got by multiplying the credit times the weight. So since an A gets 4 points, I'd do 4 times 4 to get 16 points for my 1A. I have a B in a 3-credit class, so that's 3. Each B is 3 grade points, so 3 times 3 is 9. I did another class, got a B for 3 credits, so 3 times 3 is 9. And I got a C in a 1 credit. A C counts for 2, so 1 times 2 is 2. So I'm going to add up my 16 plus my 9 plus my 9 plus my 2 to get 36 points. Those are my grade points. Now, how many credits did I try is what I'll divide by. So I had a 4 credit, a 3 credit, a 3 credit, and a 1 credit. So that's a total of 11 credits attempted. So the points you got weighted with the grade you got in them was 36 divided by the 11, which is how many credits you tried, for a GPA of 3.27. Okay, there you go. And this homework will take a little while, and you do need your calculator. Watch the little video on how to find the mean if you want, or you can just, if the data is small enough, just add and divide and it comes out okay. All right. Take care. Sorry that got a little bit out of order, but that's all right. We'll go back and do number 24. So raising your grade. Suppose you have the grades listed, 60, 70, 65, 85, 80. So what's the mean? I don't want to do the trouble of using my calculate one variable statistics. It's a small data set. So I'm just going to add these 1, 2, 3, 4, 5 grades, and I will divide by 5. So go ahead and try that in your calculator. And what you should get is the mean of these scores is 73. All right, part B says, well, what would I need on the next exam to have an overall mean of 75? I want to bring my average up by 2 points. Well, I need to know how many points I've gotten already. So if I add my 60 plus 70 plus 65 plus 85 plus 85, that was 365 that you got when you added those up a few minutes ago. If I want an overall mean of 75 over 6 grades, I'm going to multiply 75 times 6 to see how many points I need total. So 75 times 6 says I need 450 points in order to have an average of 75. Check that out. 75 times 6 is 450. So if I take that 450 and divide it by the 6 grades I'll have, that means I would have an average of 75. Well, I have 365 points already from the first 5 tests. I need 450 total. So if I subtract, that tells me I need 85 more points in order to get my mean of 75. So I can raise my grade by getting a B by 2 points. So the next question is a really good one I get all the time. If the highest you can get is on a test and somebody says, oh really, I want to bring my average up to a B, the question is, can I do that? So if the highest I can get is 100, let's see if this student can get this grade up to a B. So we'll just do the same thing we did before. We already have 365 points. So on the sixth test, give yourself 100. You now have 465 points divided by the 6. Oh dear, you get a 77.5. So with those grades, and notice you got a low D, a C, a middle D, but you have 2 B's, it's just not enough to bring your grade up even with 100. So you have to have consistently good grades in order to do that. It's very hard to bring your average up at the last minute. So good thing to know overall. All right, number 26, comparing averages. Here they give you the heights of people on the National Basketball Association here. It says that its basketball players' average height is 6'8". So on your team, the coach takes a look at your starting lineup heights as listed, and could you justify in claiming your starting lineup has the average above the NBA? Well, it's going to depend on your definition of average. Is it the mean? So add them all up and divide by, what have we got, 1, 2, 3, 4, 5. Or is it the median, the middle number? Well, if it's the mean and the 6 foot is the same, so I'm just going to add 5 plus 6 plus 6 plus 0 plus 2 and divide by 5, and see I'll get 8.6 is the mean of the inches. Oh, I lied. I had some 7-footers in there. So I would actually convert those all to inches and work that backwards. It would be 6 feet. 8.6 inches would be the mean height. Now the median height though is 6.6 because that's in the middle value. So if it's the mean, then your team is above average height, but if it's the median, it's below average height. So again, whenever anybody says average, always ask, do you mean the mean or the median? All right, this last one here is phenotypes of P's. This is nominal type data here, so we have to be careful about how we interpret it. So we did an experiment to see about carbon dioxide in soil and how the colors of the peas were affected by the carbon dioxide. 1 is a smooth yellow pea, 2 is a smooth green pea, 3 is wrinkled yellow, 4 is wrinkled green. So can the measures of center be obtained for these values? Obtained? Yes. All I do is add them up and divide by the number. I'll get the mean. The median, I'll rank them and put them in the middle. And the mode, I'll look at what's most frequent. So do the results make sense? Well, not for the mean. It's 1.9. That doesn't mean anything. I don't know if you can't have, that kind of a p. It doesn't exist. So the mean doesn't make sense. The median is 2. Well, that's just the middle value. What you would really want to see is what happens most often. So you're looking for the mode, and that makes sense because the mode of 1 indicates that the most type of P I'll get is a smooth yellow at that nominal level. Because remember, they're just representing a color, nothing else. Okay, thanks so much, and I hope this went well. I had a few interesting glitches on recording this. Bye.